Okay, next is the algebra of limit. Let D be a subset of R and f and g are two functions on D to R, and let C be a belongs to dx, means C either belongs to D or is the limit point of D, and limit extends to C fx is equal to L, limit extends to C gx is equal to M. Then limit extends to G f plus g of x, that is f plus g of x means that is nothing but fx plus gx goes to L plus M. That's called the sum of the algebra. Algebra of the limit means we will see what is the addition, subtraction, multiplication and division of two limit. So if that function fx goes to L, gx goes to M, then the sum of the function goes to L plus M. We'll prove this one. Okay, given us, let choose epsilon greater than 0. We need to show that f plus g of x minus L plus M of mod is nothing but what? Fx minus L plus fx plus g of x minus L minus M. That can be written as fx minus L plus g of x minus M. And by the triangle law of inequality, we can see that this is less than or equal to fx minus L plus g of x minus M. I need to show that this is less than epsilon for some delta. Now given that limit extends to C, fx is equal to L, and limit extends to C, g of x is equal to M. So this limit exists, this limit exists. Meaning है there existed delta 1 positive and delta 2 positive. Delta 1 for the first limit and delta 2 is for the second limit. Now what happened that fx minus L each less than epsilon by 2. I can write it as epsilon by 2, less than epsilon by 2. We likhi parma for all x belongs to the deleted neighborhood of C of the radius delta 1 intersection with D, and similarly we have gx minus M is less than epsilon by 2 for all x belongs to the deleted neighborhood of C of radius delta 2 intersection with D. Now this x belongs to the delta 1 neighborhood of C, this x belongs to delta 2 neighborhood of C. So let delta is equal to minimum of delta 1 and delta 2. Now for this delta, this two statement will true simultaneously, because I am already discussed why we are taking the minimum of delta 1 and delta 2. Each जिनिस delta 1 neighborhood lagi true होचे, and this is true for delta 2 neighborhood. Means दुई statement एका संगे true हवा for the delta is the minimum of delta 1 and delta 2. For delta equal to this, what happened? We have that fx minus L is less than epsilon by 2 and g of x minus M is also less than epsilon by 2 for all x belongs to, now I can say that delta neighborhood of C intersection with D. Now from equation 1, what's that one? F plus g of x minus L plus M mod is less than or equal to fx minus L is now less than epsilon by 2 plus epsilon by 2 strictly less than is equal to epsilon, and this is true for all x belongs to the deleted neighborhood of C of radius delta intersection with D. Hence I can say that limit x tends to C, f plus g of x is nothing but L plus M. So the sum of two limit is equal to L plus M. But the interesting thing is that we will see some example note. Given that limit x tends to C, f plus g of x exists. मतलब जदि देई थिबा limit x tends to C f plus g exists, in that case आमे ई जागा रे कहि न पारो कि both limit must exist. Then if this is true, then it may happen that both limit x tends to C fx and limit extends to c, gx does not exist. It may happen both of these limit doesn't exist, but the sum of the limit exists. Okay, so we will give an example set limit x tends to 0. We know that limit x tends to 0, 1 by x does not exist. I am giving just simple example. And also we know that limit x tends to 0, minus 1 by x also does not exist. This is fx, this is gx, but the sum of the function, what is that sum of these two functions? Limit x tends to 0, fx plus gx, that is 1 by x, plus minus 1 by x, that is nothing but a constant. Limit x tends to 0 is 0, that is equal to 0. It exists. So I am just giving a simple example where the sum limit of the sum function exists, but the individual limit does not exist. We can give more example right here. Suppose the discrete function fx is equal to 1 x or 1 if x belongs to rational number, minus 1 if it belongs to irrational number. We can prove that limit does not exist at any point of the real number, at any point. And I am taking gx is equal to minus 1 if rational, 1 if irrational number. What's the sum of these two functions f plus g of x? Is nothing but 0 for all x belongs to real number. We can see here that limit x tends to c, fx does not exist for all c belongs to the real number. Same, limit x tends to c, g of x does not exist for all c belongs to the real number. But what happened to the sum of the function limit x tends to c, f plus g of x is nothing but a constant, that limit x tends to c, that is nothing but 0, equal to 0, exists for all x belongs to or for all c belongs to R. So we have seen that the sum individual limit does not exist, but the sum of the limit exists everywhere. And another point we will have that if limit x tends to c, f plus g of x exists and limit x tends to c, fx also exists. In that case, some of the limit exists and one of that function fx, limit x tends to c, fx exists. Then it is bounded. Then it must have limit x tends to c, g of x must exist. So if the sum of the limit exists and one of these limit also exists, then another limit must exist. Means empty gote case nae no jenja sum of the limit exist korba gote limit exist korle aro limit exist nae korthuba example amar pakhe nae no. How we prove this one? Dekho बहुत simple proof hoche. The sum of the limit exists, this fx exists, and limit x tends to c, f plus g of x exists and fx exists. Then the subtraction also exists. That is nothing but limit x tends to c, g of x must exist. Okay, so next we'll see another example for the algebra of the limit for the product. Okay, we have just another theorem that limit x tends to c, fx into gx is nothing but L into m, where f and g both are the functions from D to R, and where f into g of x is nothing but fx into gx. This is not the composition, just the product of the two functions. And we have given that limit x tends to c, fx is equal to L, and limit x tends to c, g of x is equal to m. We have the same thing. Now proof of this theorem was that fg of x minus L into m, that is nothing but fx into g of x minus L into m. Okay, just I am writing it is as fx into g of x minus L into g of x plus L into g of x minus L into m. Just I am adding just term minus L into gx, add करली and subtract करली. Now this is nothing but gx common asla amar pakhe. This is nothing but fx minus L plus L common asla gx minus m. By the triangle law of inequality, this can be written as mod of gx into mod of fx minus L plus L common asla g of x minus m rho mod. Okay, now we'll find some condition to show that this is less than epsilon. Okay, given since limit x tends to c g of x exists is equal to m exists, I can say that exists. So we have seen that if this limit exists, then the function is bounded. Then implies g of x is bounded on some neighborhood of c. That means g of x mod of gx is less than or equal to b for where b is some positive number. For all x belongs to, say, index of c delta 1. Index number for every neighborhood where c is defined. And c of delta 1 intersection with d. Okay. And again now we'll go for it. Now limit x tends to c, fx is equal to L. That means there exists a delta 1 positive such that fx minus L is less than epsilon by b. I will take epsilon by b. Jenda b amar bari chhe. Epsilon by b for all x belongs to the index of c delta 1 intersection with d, and limit x tends to c, g of x is equal to m. That means there exists a delta 2 positive such that g of x minus m is less than epsilon by L. I am writing epsilon by L for all x belongs to the deleted neighborhood of c of radius delta 2 intersection with d. Then choosing same in the process, will choose delta is equal to minimum of delta 1 delta 2. Okay, we have to already check in delta 1, so I will choose as delta 2 and we will choose as delta 3. So we choose the delta 1 comma delta 2 comma delta 3. Okay, now for these delta, each of the every statement is correct. Hence from equation 1 I am writing it is now f into g of x minus L into m is less than mod of gx is nothing but less than b for this delta 1, and delta is minimum of delta 1 delta 2 delta 3. So this for this delta, this thing work b into fx minus L is less than epsilon by b strictly less than plus L into this is less than epsilon by L. Oh, I am writing just epsilon by 2b and this is 2L in order to make it epsilon. Okay, that's epsilon 2 plus epsilon by 2, that is nothing but epsilon, and that is true for all x belongs to the deleted neighborhood of c of radius delta intersection with d. So hence I can say that limit x tends to c, f into g of x is nothing but L into m. Some note point in the same regarding the last for the addition, we have that if limit x tends to c, f into g of x exists, then it may happen limit x tends to c may happen both of the limit fx and limit x tends to c gx does not exist. We'll give an example, that simple example, and then we go for the difficult example. So fx is equal to again 1 if x belongs to rational minus 1 if x does not belongs to rational. Same gx I am taking that. Reverse one, minus 1 if x belongs to rational and 1 if belongs to irrational. Then fx into gx is nothing but we have for everyone this is minus 1 for all x belongs to R. Limit x tends to c, fx does not exist for all c belongs to R, and limit x tends to c, similarly gx does not exist for all c belongs to R. Okay, but limit x tends to c, fx into g of x exists for all c belongs to R. Okay, now the second note point, it may happen that if limit x tends to c, fx into gx exists, then it may happen that limit x tends to c, fx exists, but limit x tends to c, g of x does not exist. Like in the last example for the algebra addition, so if this fx plus gx exists, then it may not happen that one of the limit exists but another does not exist. But in case of multiplication, it may happen that the product of this limit exists, one of the limit exists, then it may happen that g of x does not exist. For example, if I take limit fx is equal to 1 by x, limit x tends to 0, 1 by x does not exist, and as we have seen, g of x equal to x, I will take x, limit x tends to 0, x, that is nothing but 0, exists. Okay, limit x tends to c, 0, fx into gx is nothing but 1. It exists everywhere. Exists. So the product is exist, the gx exists, then fx here does not exist. So it may happen that one of the limit exists but another does not exist. Now in the next one we will show that the divisibility of these two existence of limit. So in the next one we have that let d belongs to R, f and g are two functions on D. G of x is not equal to 0 for every x belongs to D, because we are finding that f by g of x, that is nothing but fx by gx. That's why the denominator cannot be equal to 0 for all x belongs to domain. Let c belongs to dx, and that limit x tends to c, fx is equal to n, limit x tends to gx is equal to m is not equal to 0. Then limit x tends to 0, f by g of x, that is nothing but fx by gx is nothing but l by m. We will prove this one. To prove this one, first of all we will prove that we will show that limit x tends to c, 1 by g of x is nothing but 1 by m, and rest then we'll use the product rule to show that fx into g of x, 1 by g of x is equal to l by m. So first we will show this one. Let was that 1 by g of x minus 1 by m is need to be so then less than epsilon. This is nothing but mod of gx minus m by mod of gx into m, mod m. Okay, let us choose p be a number 1 by 2 times of mod m, and here p is positive. Since limit x tends to c, g of x is equal to m, so there exists, this p is nothing but like epsilon, there existed delta 1 positive such that mod of gx minus m each less than epsilon. Epsilon is nothing but mod m by 2. For all x belongs to the deleted neighborhood of c of radius delta 1 intersection with d. Again, mod of gx mod minus m mod whole mod is less than equal to mod of gx minus m is less than mod m by 2. Hence nothing but mod of gx minus mod m is less than mod m by 2 greater than equal to minus mod m by 2. This for this one, this since mod x less than a means that x lies between minus a to a. So this is less than mod m by 2. So I am writing mod m plus mod m minus mod m by 2 is less than mod of gx is less than equal to mod m by 2 plus mod m. So we have easily see that modulus of gx strictly greater than or equal to mod m by 2. Okay, this is greater than mod m by 2. Let it be equation 1. Okay, again let us choose epsilon greater than 0 since limit x tends to c, g of x is nothing but what? We have that m. There existed delta 2 positive such that g of x minus m is less than epsilon by 2 such that g of x is less than something. What we will take 1 by 2 times mod m square into epsilon. Why we have chosen so this number I seটা পরে discussion করমা but কেনতা আসলা আমি বতামি. For all x belongs to the deleted neighborhood of c of delta 2 radius intersection with d. Okay, এই জিনিসটা কেনতা আমি নেলা সেই জিনিসটা আমি discussion করমা, purely discussion করমা. Now let delta is equal to minimum of delta 1 comma delta 2. Now for these delta, this statement and this statement holds simultaneously. So what we have then 1 by g of x minus m is nothing but what we have that mod of gx minus m mod by mod of gx into mod m. Okay, 1 by mod gx, 1 by mod gx is greater than mod m by 2 implies 1 by mod gx is less than 2 by mod m. Reciprocal. So this is less than, so this is less than. Now this one is less than what? Mod fx. এই জিনিসটা আমি কেতে নামা আমি ডিসাইড করব কৌতুলো আমি. তো this by mod x less than 2 by m square, so 2 by m square m. 1 by mod gx is less than what? 1 by mod gx is less than 2 by mod m. So 2 by mod m square, 2 by mod m square but I need to less than epsilon. So what should I take mod gx by mod gx minus m? This is epsilon by 2 into mod m square. So that sorry mod m square upre haba, so that kana haba cancel ei jiba, eta cancel haba less than epsilon haba. So that's why we have taken mod gx minus 2 is less than epsilon into mod m square by 2. Epsilon into mod m square by 2 less than epsilon, and that is true for all x belongs to the deleted neighborhood of c of radius delta intersection with d. Hence I can say that limit x tends to c 1 by gx is nothing but 1 by m. Now limit x tends to c fx by gx can be written as limit x tends to c fx into 1 by g of x, and that goes to 1 by m, this goes to l. This is l into 1 by m, that is nothing but l by m. So this is all about the algebra of limit. The same thing here proof means note, I am not writing this one again. Same thing that we will have example that where f by g of x exists limit, but the individual that limit extends to cfx, limit extends to cg of x may not exist. And for the same in the case of product exists, one of the limit exists, then it may happen that another limit does not exist. So we may have an example that fx by gx limit exists, fx limit exists, and g of x limit does not exist. So this is the algebra of limit. In the next class we'll see some more important theorem regarding the limit. Thank you.